Welcome to Algebra 1, Unit 3, Lesson Topic 5, Percent of Change. I'm Mr. Pilarski and I'm your math teacher. Our objectives today are, I will be able to identify the percent of change as increase or decrease. I will be able to find the percent of change. Let's check out how we can support these objectives through example. Here we're given the percent of change proportion. That proportion is the amount of change over the original value is equal to the percent of change over 100. Similar to the percent proportion we worked with earlier, part over the whole is equal to the percent over 100. Here we're talking about a percent of change, when things increase or when things decrease. For example, real simply, if I had something that went from, let's say, $2 up to $5, the way I would set up this proportion to find the percent of change, I'm being asked to find the percent of change here, would be x here, and the original value. Since I started at $2, the original value is 2. The amount of change, this value, we have to calculate that with subtraction. So we'd have to go 5 take away 2, that'd be an amount of change of 3. So it'd be 3 over 2 is equal to x over 100. Then I'd solve the proportion. 100 times 3 is 300. 2 times x is 2x. Divide each side by 2. X would be equal to a 150% increase. Okay, that's what we're going to be working with here in this lesson. In example 1t, we're going to be finding the percent of change. Suppose Mr. Hanson's weight went from 185 pounds to 200 pounds. What was the percent of increase in his weight? So we're told in this problem that we're looking for a percent of increase, and hopefully you would be able to figure that out. His weight started at 185 and it ended at 200. So setting up our proportion here, we're asked to find the percent of change. What is the percent of increase? So x over 100 on the right hand side. On the left hand side, the original value, or Mr. Hanson's original weight, is 185. What we have to calculate is this amount of change. And we get that by going 200, take away 185. I know some kids, they can just rattle the answer to that off knowing that it's just 15. Other kids need to actually use a calculator or do what I'm doing here by regrouping or borrowing, if you will. 10 take away 5 is 5. 9 take away 8 is 1. When we borrowed, that leaves us with 1. Take away 1 for nothing. So the amount of change is 15. So now we solve our proportion. And when we multiply here, we get 100 times 15 to get 1500. 185 times x to get 185x. And we divide each side of this by 185. We get x to be equal to, and now this is an approximate, I divided that out on a calculator and rounded it to 1 decimal place. And so it becomes 8.1. So Mr. Hanson increased his weight by 8.1%. Key thing in these problems is you have to calculate the amount of change. You have to calculate the amount of change. Example 2t, we have some real-world problem solving with percent of change. It says between 1940 and 1980, the federal budget increased from $9.5 billion to $725.3 billion. What was the percent of increase in the federal budget? So we're asked to find the percent of increase here. So setting up our proportion, has to find the percent of increase, so x over 100 on the right-hand side. On the left-hand side, we have to decide which of these numbers is the starting value. Now it says between 1940 and 1980. Well, we're going to eliminate these numbers because they're years. They're important, but not for our calculations. The federal budget increased from 9.5 billion to 7.25 or 725.3 billion. So the way this is ordered, the years 1940, 1980, and then this would be 1940 and this would be 1980. So the starting value for the federal budget is 9.5 billion. What we have to do is figure out the amount of increase or the amount of change. And we're going to do that by subtracting these two values, 725.3 billion, take away 9.5 billion. When we do that subtraction, that gives us 715.8. And of course that would be billion. So this is the amount of change. This is the number that needs to go in the numerator. Now that number is considerably larger than the starting value. So we should expect a percent that's going to be considerably larger than 100. So let's figure this out. 100 times 715.8 billion. It's going to be that number. 9 times x is going to be 9.5x. Divide each side by 9.5. Here again, we're going to use a calculator. No point in doing that ridiculous calculation by hand. And what that gives us is 7,535%. Or, just about a 7,500% increase in the federal budget.